ship in the air towards the lightning generator, which is above it, or laying sort of on its side like a 30-degree angle. Way different results in the lightning protection system, how efficient that it was. As a blade moved from directly pointing straight up towards the sky where the lightning generator was, that worked pretty well. As soon as you start to rotate off of that, you start having big changes in the efficiency of the lightning protection system. So it points out a couple of things. It sort of highlights the really key facts here. All these lightning protection systems they were testing essentially have basically a cable, a copper cable running up and down the blade. And then they have something at the end of the blade, it would be a receptor or a metallized tip at the end. And that copper conductor, the down conductor that's stuck inside the blade, even though you can't see it, it's still active. Lightning can see that thing. It's essentially what it boils down to. Lightning can still see that thing. So as you move the blade from pointing straight up to pointing on its side, that cable, that down conductor in the blade is still as attractive as ever. In fact, it's probably working harder than the luminized tip or the single receptor at the blade end in terms of being attractive. That is a big deal, right? So what they were simulating in the lab is actually something we have seen in real life data coming back for the field, which is we're seeing lightning strikes on sort of standard blade protection systems where we have a receptor near the end of the blade. Those receptors aren't as efficient, and it looks like there's really two reasons why. One is the polarity, what the polarity of the lightning event is, because sometimes depending on how the cloud is formed, usually the positive is up high and then the negative charge is down low in the cloud, but those can flip over, and there's a lot of variation in that. And then the second is just the orientation of the blade, where it is relative to the cloud seems to make a big difference. So it tells you that you really have to do your homework in terms of lightning protection. You need to be looking at not the easy configuration, which is point the blade up in the sky, see if something hits it. Yeah, okay, great, looks great. Off we go. What happens in real life and what they have found in this paper is that as you get in real world situations, the probabilities go down in terms of the efficiency, which means the likelihood of having some sort of structural damage to the blade goes way up.
Yeah. Just more variability of where it can hit it and just the way it's going to hit it and all that stuff.
Yeah. And I think the interesting thing about it is that